8, Section 1, talking about graphs of equations. We're going to begin with a review of the Cartesian coordinate system. The Cartesian coordinate system, it is formed by the intersection of a vertical and horizontal number line, the y-axis and x-axis. The intersection point is called the origin, so that point right there. The plane is divided into 4 sections called quadrants. So in the top right is where we start, and that is quadrant 1. And then we go counterclockwise, quadrant 2, quadrant 3, and quadrant 4. So the quadrants are commonly represented with Roman numerals, but you can write them as just regular 1, 2, 3, 4. Points on the Cartesian coordinate system can be identified with a combination of their horizontal and vertical distance from the origin. Points are notated with the ordered pair x, y. X measuring the horizontal change or movement from the origin, y representing vertical. So if we want to plot a few points and tell the quadrant where that point lies, the point 5, 2, starting from the origin, the x value is 5, the y value is 2, so that lies in quadrant 1. The point 4, negative 2, so x value is 4, the y value is negative 2, that's in quadrant 4. Zero, negative 3 is not in any quadrant, it is on the y-axis. When we talk about the graph of an equation in 2 variables, x and y are our variables, it's the set of all ordered pairs that satisfy the equation. So, my example, determine if the following point lies on the graph of y equals x squared plus 3. So our point is negative 2, 1, so I'm going to substitute in, and I'm going to see if this is true or false. Well, that's 7, so my answer is no. When we go to graph, what we're going to do by plotting points is we're going to choose values for the variable, usually we choose for x, and substitute into the equation. We're going to solve and find values for the other variable, usually the y. We're going to choose between 3 and 5 different values. So I'm going to be choosing 5 just for starters. So I'm going to organize my information with a table. I get to pick numbers, whatever numbers I want for x. So I'm going to kind of make life easy on myself. I'm going to definitely pick 0 and 1 and 2. But to get kind of a well-represented solution, I'm also going to pick negative 1 and negative 2. So that way we're centered around 0 with a couple of points on either side. So I'm going to put in these numbers for the x and solve it out to get my answer for the y. And then I'm going to find my graph paper. And I'm going to plot these points and connect them. I notice that my y values, kind of bigger numbers, -11 is how far down I have to go. So I'm going to count or scale by 2's on the y-axis. I'm going to plot my points. And I notice that they all end up in a line, a straight line. So I'm going to draw the line connecting through those points. Now we have seen how to graph a function like this in an earlier chapter. We would know that the y-intercept would be -5 and the slope would be up 3/1. But as we're going to see shortly, we're not going to end up with all lines in this section. We're going to end up with some different shapes. So letter B. Making my table, and I'm just going to pick the same numbers I'm going to plot these points. And I'm just going to go by ones this time. So I have a point -2, 5, -1, 2, 0, 1, 1, 2, 2, 5. This time I get kind of a curvy U-type shape. This is actually, the graph is called a parabola, which we'll discuss more in a later chapter. Anytime you have an x being squared, you should expect this shape of graph. Part C, so this time we have an absolute value. And anytime I have either absolute value, or if I had parentheses up here on letter B, if there was like parentheses with the squared on the outside, anytime you have that type of grouping symbol, you want to use the number that's inside the grouping to help you to pick your x values. So since this is, I'm going to use the opposite sign. Since it's 6, I'm going to pick x values around 6. So 6 is going to be in the middle. 5 and 4, 7 and 8. The reason I do this, we'll see shortly by the shape of the graph. I think I can scale by ones again, so I've got my graph big enough, so I'm going to go ahead and plot my points. And this time, my points make a V shape. So it's different. This last time on part B, it was a U shape, because I couldn't make a straight line. If I find my straight edge, I can't connect all 3 of my points with a straight line on part B, so that's how I knew it was curved. Whereas part C, I can connect them with a straight line. So I have a V-shaped graph. Every time you have absolute value, your graph will be V-shaped. And section 8.1 getting kind of long, so we'll go ahead and pause it here and pick up with the rest in the next video.